Okay, welcome back. Let's talk about prime factorization. Prime factorization is the same thing as factor trees. So if you've heard one or the other, that's what we're going to be talking about today. So prime factorization is literally just factoring things or breaking big numbers down to their prime numbers. We're factoring to primes, prime factorization. We're making trees out of those factors, so factor trees. So let me give you an example based off of a previous assignment that I've given. Let's say that we're trying to find the prime factors of 44. When we're thinking about this, we should always be keeping in mind what our first five prime numbers are. So our first five prime numbers are always 2, 3, 5, 7, and 11. And these are our prime numbers because what a prime number is it's a number that can only be divided by 1 and itself. Now we're talking about whole numbers here, talking about integers. Sorry, we're talking about whole numbers, but the only numbers that it can be divided by and still give us a whole number back is 1 in itself. So the reason 4 isn't part of this is because 4 can be divided by 1 itself and 2. 6 isn't part of this because it can be divided by 1 itself and 2 and 3. So do you see where we're going with this? So 2, 3, 5, 7, and 11 are our first 5 prime numbers. And this is usually what you're going to want to use to try and factor things down. If you don't look at a number and automatically know, oh, that's divisible by such and such, then what you want to do is you want to start using these first prime numbers and divide those into that number to see what fits. Okay, so 44. 44 I already know is an even number. Even numbers are divisible by 2. So if I divide 44 by 2, then what's left over is 22. I'll explain the rest here in a minute. Okay, so 22, 2 is prime. So I circled that because I can still break that down. In some of the worksheets, there's a rectangle surrounding what you can still factor down. So 22 is also an even number, so I can divide that by 2 as well. If I divide 22 by 2, it's 2 and 11. If I divide 22 by 2, then I get 11. If I multiply 2 and 11, I get 22. See how this goes? So this is like an upside down tree or the root system of the tree. And it's kind of fun to call it the root system of the tree because we're going to be using this to break down square roots by hand. Okay, so there are other ways to do these factor trees, but you're still going to end up with the same results. So let me show you. So if I say, okay, well, 44 is right here. Well, instead of using 2 and 22 this time, I could say, I could break that down to 11 and 4. And 4 breaks down into 2 and 2. Can I break 11 down? No, because that's one of my first 5 prime numbers. And it's a prime number whether it's the first 5 or not. But 11 is a prime number. I can't divide it by anything except 1 in itself. And 2 are prime numbers. So both of these 2's are prime numbers. So in the end, no matter which way I do it, the numbers that I'm left with are 11 and 2 2's. So these are my factor trees. These are my factors. These are my prime factors. So 11 times 2 is 22, times 2 is 44. 2 times 2 is 4, times 11 is 44. So no matter how you multiply these together, you will still get the same answer. But so long as you break them down to their prime numbers, you'll always get the same answer. The reason that we do this is because what we're going to be working on next is we're going to be breaking down, like I said, square roots by hand. So let me show you an example of what that looks like, and then you can watch this as many times as you need to kind of get used to it. Okay, so let's say I have, whoops, let me bring down my brush size a little bit again. Let's say I've got the square root of 147. I look at that and I say, well, it's not an even number. I don't know what I can divide it by. but I'm going to write down my first prime numbers. So let's see, 2, 3, 5, 7, and 11. So I'm looking for numbers, for prime numbers that I can divide into this and get something back. I know I can't divide it by 2. Let me try by 3. So I'm going to get my calculator and I'm going to say, okay, 147 divided by 3. Does that give me a whole number? Lo and behold, it does. So if I break this down, 147 divided by 3 is 49. 3 is prime. I'm going to circle that so that I remember that it's prime. 49 is not. If you're not sure if it's prime or not, keep trying to divide those prime numbers in until something falls out. So I can't divide it by 2, I can't divide it by 3, I can't divide it by 5, but I try and divide it by 7. 49 divided by 7 is 7. Or some of you will just see 49 and go, oh, that's 7 times 7. And so you'll know how to break those down. But this is why if you don't know multiplication and division, you're going to really struggle with this unit. So if you need to, please go either find me and ask me for some ways to get better at multiplication and division, or go out into the World Wide Web and find some examples there. Okay, so when we're simplifying square roots by hand, the factor tree is only the first step. Our second step is going to be to line these back up underneath the radical, underneath the square root sign. So this is the square root of 3 times 7 times 7. Please remember that we've talked about how square roots and squares are equal and opposite. So if I take the square root of 7 squared is 49. The square root of 49 is just 7. And so if I take the square root of a square, all I'm left with is the base number. This is going to be really important because what we're doing now is I'm going to circle two numbers at a time, because 7 times 7 is 7 squared. And it's underneath a square root, right? So I literally have the same situation where I have a square underneath a square root. So what's going to happen is that 7, my base number, is going to leave the square root. It's not going to break the square root for anything because we still have the square root of 3 under it, right? So it doesn't destroy the square root, it just gets rid of the square root for the 7s. Okay, so I'm going to erase this so I have some more room to work. And the number that I'm left with, so I have my 7 on the outside here, my square root sign, and I still have a 3 under the square root. And so this is my simplified answer. I don't have any more pairs of numbers I can circle. I don't have any more things to simplify, either inside the radical or outside of it. And so this is my final answer. So first step, factor tree. Second step is to look for pairs, to rewrite the radical and to look for pairs so that you can bring one outside of the radical. And the third step is to simplify it if you need to. Simplify your results. Everything involved in this process is multiplication. So if I had another number outside of the radical, I would just multiply that to the 7. Okay, so that's the lesson. Go to and do.